In this video, we're creating a complete Azure portfolio so you can build projects to show off your skills. You'll create a website, use Azure services, build with AI, and so much more. Now we have a lot of ground to cover, so let's dive in. So why a portfolio website? Well, a portfolio website gives you full ownership of your piece of the internet. This is different from social media accounts where the way you display who you are and the way you demonstrate your skills is dictated by the way the social media platform is set up. With your own website, you have full ownership to control the way you display who you are and what you know. This creates massive differentiation for you because most people don't have a website or any way to showcase their skills. This website becomes the home for your portfolio to showcase what you know and the skills you're currently acquiring. This wows employers and anyone that you might work with in the future. Having a website makes you more professional. It's like a business card, but on the internet and with more information that you can share on it. And your personal website demonstrates some level of technical skills that you have simply by existing. When it comes to building your personal portfolio website, there's two paths that you can take. You can create a custom build where you might use a web framework or native JavaScript to build and code the whole website yourself. Or you might use a website builder where there's less code involved and more click and drag functionality. If you choose to do a custom build for your website, there's three very popular website frameworks that you can use: React.js, also known as React, Angular, and Vue.js. For the portfolio we build in this video, we'll be using React. Choosing a website builder will require you to think through if you want more control, customization, or more ease of use, low code, no code, and click and drag functionality. Some example website builders that fall within this spectrum are WordPress, Squarespace, and Wix. There's a lot of other website builders out there, but these are three that are reliable and commonly used. To follow along our demo, you'll need the following things: Visual Studio Code or some other text editor, an Azure account, which will host your Azure Static Web App and portfolio projects, a GitHub account to house the repo for your website and your projects, Node.js and Git installed wherever you're coding with Visual Studio Code, whether that's in the cloud or locally. Now let's get started building. This GitHub repository is a template for a custom build website using the React Web Framework. We'll use this template to create a demo portfolio website for a fictional person named Mason Stark. We'll copy the repository URL, and in VS Code, we'll clone the GitHub repo. We'll enter into the repository, and we have an existing Git history from the templated repository on GitHub. We want to remove the old Git history to create a new Git history so that we can have a fresh repository for our website. To do this, I'll run a remove item command in the Windows PowerShell. This command is slightly different on Mac using the rm command. Then I'll create a new Git repository locally. Now to get this up and running, let's install the local packages. We'll run npm install, and when that's done, we'll start running the website template locally. The libraries were installed. Now let's run npm start. This is what our website looks like running locally. And now that we see that it's working, let's commit it to our own GitHub repository. Now let's create a new GitHub repository. I'll make myself the owner, and I'll call it demo Mason Stark website. You could choose to make this private if you don't want people to see how your website is built. Or you could leave it public if you want to showcase your skills with your portfolio website. I'll leave this as public and create this repository. Next, I'll copy the URL for the repository, and in VS Code, I'll connect my local GitHub repository to my GitHub repo in the cloud. Then I'll commit the changes locally. and push the changes to the cloud. Now, if we update the GitHub repository, we should see the code in there, and we do. Next, let's make changes to the templated website with Mason Stark's information. I now have the local website running with the changes I made with Mason Stark's information. You can see now I have Mason Stark at the top. It says, welcome to my portfolio. The navigation shows about with a picture of Mason Stark, and then I have Project 1, Project 2, and Project 3. These will go to portfolio projects that will fill in later videos. To make these changes, I created a Project 1, Project 2, and Project 3 file based on my About page and made some small tweaks and adjustments. I added styling for each of those projects, which is also based on the styling that the About page has. Commented the contact page because we'll update that in a future video. In the app.js page, I added the projects. In the About page, I added the new image. In the data.json file, I added information for the projects, and I updated the header title, the header paragraph, and the About Me paragraph. In the header.js section, which is what this Learn More button takes you to, I updated the hyperlink to go to the About page. And in the navigation component, I removed navigation for components that no longer exist or that we're not using, and added in navigation for the 3 projects we'll have. Now let's push these changes to the GitHub repository. Something I forgot to mention is that I removed this .github folder from the templated repo before I made changes and committed to my repository. You'll want to remove this .github folder before you deploy to Azure Static Web Apps so that there's no conflicts related to your GitHub actions and your workflows to automatically deploy to Azure Static Web Apps. With all the basic changes made to our Mason Stark portfolio website, let's deploy an Azure Static Web App using this code. I'll go to the Azure Marketplace in the Azure portal, and I'll search Static Web App. Let's create a static web app. I'll create a new resource group, calling it Demo Mason Stark RG for resource group. I'll call the static web app Demo Mason Stark Web. I'll use the free plan. We'll connect our GitHub repository that we created. Azure Static Web Apps detects that we're using the React Web Framework. We can leave all the defaults and review and create. Our deployment is complete. I can go to the resource, and our deployment should be deploying in the background. If I grab this URL and go to it, we'll see that there's a landing page set up for Azure Static Web Apps by default, but if we come back in a little bit, it should deploy our website. It's been some time and I refreshed the page, and now I can see Mason Stark's personal website is up and running as an Azure Static Web App. Our final step for our demo portfolio website is to add a custom domain name for Mason Stark. Let's go over to the Azure Static Web App in the Azure portal. We'll go to Settings, Custom Domains, and we'll add a custom domain name. We'll add it from another DNS provider, masonstark.com. We'll generate a TXT record. This TXT record will be used to validate that I own masonstark.com, which, if your name is Mason Stark in real life, I have your domain name. Reach out to me, let's talk. I'll copy this to my clipboard. I'm using Namecheap for masonstark.com. Now let's add a record, TXT record, host with the value. Save it. Now we'll wait until Azure picks it up. And once they do, we can move on to our next step by adding an alias record for the domain name. We might need to wait a little bit for this to happen as the TXT record gets propagated throughout domain name servers. The TXT record validated that I owned masonstark.com. Now let's add an alias record for my custom domain name. I'll add an alias record, the host, save. And in a few minutes, I should be able to go to masonstark.com to go to our demo portfolio website. Let's try it now. And it's working. I can see masonstark.com has our demo portfolio website up and running. I can go to the About section, Project 1, Project 2, Project 3, and in coming videos, we'll populate our portfolio website with these projects. Our portfolio website is up and running. Now let's create our first portfolio project, which is going to use Azure Logic Apps to set up a simple automation to send an email when a Microsoft form is filled in and submitted. All right, to get started, let's create our Microsoft form. So in Microsoft Forms, I'll come and create a new form. I'll make it text. We'll title it Demo Fruit Growth Expert. And that's it for our form. When we're ready to add the form URL to our portfolio website, we can come to Collect Responses, and we can grab the long URL or hit this button to get a shortened version. Next, let's create the Logic app. I'm in the Azure portal in the Marketplace. Let's search Logic app. I'll start creating a Logic app. I'll choose to use the consumption version because I'd like to pay per operation for this Logic app. I'll create a new resource group. We'll call it RG for resource group, demo, Logic app, form responder, Mason Stark portfolio. We'll make the Logic app name demo form responder. And then we'll leave the defaults and create. We can go to our resource now that it's done being created. And now let's use the Logic App Designer to create our Logic app. If you're a more advanced user of Logic apps, you can also use the code view. We'll use the Logic App Designer in this video. So first, let's add our trigger, which will be our form. So in our trigger search bar, I will search Microsoft Forms. I'll select the trigger of when a new response is submitted. I'll have to sign in to make this connection to the Microsoft Forms. Pick your form, or demo fruit growth expert form. Now let's add an action to get the response details. Selecting our form again. And we'll get the list of response notifications. This action will make all of our answers from the Microsoft form available as dynamic variables that can be easily selected throughout the rest of our Logic app. Next, let's create an action for Azure OpenAI. We'll start with adding the action, which is creates completion for chat message. And we're going to need to start by creating a connection to an OpenAI resource. So first, let's create our Azure OpenAI resource in Azure AI Foundry. I'm in Azure AI Foundry, and now let's deploy a model that we can use as our OpenAI resource in our Logic app. Let's use GPT-4o Mini. This is an advanced model that doesn't cost too much and can do a lot for a little. Call it demo GPT-4o Mini form AI. Now this part can be confusing. The connection requires an Azure OpenAI resource name and an Azure OpenAI API key. The resource name is the name of the AI resource that is associated with the model that we're deploying. It's not the model that we deployed itself. and then it's the API key for that deployed model. So going back to Azure AI Foundry, we have our API key here, which is currently secret, but the resource that is actually being used is this test MS portfolio AI resource. That is the name of our AI resource, whereas our deployment name is right here. So let's copy from the URL the name for the resource. We'll add that as our resource name, and we'll get our API key, and we'll add that, and then we'll create this new connection. Now we need our deployment ID, and the deployment ID is the name of the deployment. So this is where we take the name of the deployment and add it. We also need the API version for this deployment, which you can find in this code example. Now our goal is to have someone fill out a form about what type of fruit they want to grow. We want to instruct this AI model to take that information as context and respond with instructions on how to grow that fruit and format it in an email so that can be sent to a user. To do this, we'll create a system message that tells the AI model that it's a master gardener that knows how to grow fruits and how it'll give the step-by-step instructions that will be provided in HTML format for an email. We want to sign its name with growth expert, AI growth expert, and address the email to the name of the person that was listed in the form. So we'll come over and add the name. We'll also add a user message which prompts the AI model for what we're asking. I'll add the dynamic details of what fruit we want to learn so that the following message from the AI model will give us the email we're asking for. Next, let's create an Outlook action so that we can send an email with the output from our Azure OpenAI model. I'll type send an email. We'll say Outlook, send an email v2. We'll create a connection to our Outlook. Now that we're connected, let's make the email to the email that was listed in our form. So I'll get the dynamic variable from the response, what is your email? I'll make the subject, here are your growth instructions, and I'll make the body also dynamic content from our AI model, the contents of the message. This creates a for each action because there's multiple items within an object called choices, which is the output from the Azure OpenAI action in our logic app. We care about the last item where we will only pull out the content from the message, and this is what will appear as the email. We'll save this, and we're now ready to give this a test. Now let's give our form a try. I'll fill in the details. Mason Stark. This is just a dummy email that I have for Mason Stark. Let's learn about apples. So we'll submit this and come over to our logic app, refresh the page, see that we have a logic app running. We can see it looks like it was successful. If I go back to run history, I can see it succeeded. So we should have an email if we check Mason Stark's email. And here we are. The email that was sent with generated instructions on how to grow apples. One thing I'm noticing is it looks like this email template that was generated has these strange --HTML before the actual HTML that is outputted. I can see it down here as well. I want to remove that, so I'll add a note to the system message to not add that. So back in our Logic App Designer, we'll come here at the end of the system message. Do not include --HTML or --@ beginning or end. We'll save this, and we'll try it again. And I can see in this email, there is no unique characters at the top here with that dash 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 HTML at the top or at the bottom. So you need to get clever sometimes with the way you craft your system messages so that the AI model knows how to act the way you want it to. Now that we have this working, let's add it to our portfolio website. I'm within the code for the fictional online portfolio website for Mason Stark, and I'm going to add the Logic app, a picture of it, some of its features, and some functionality so someone can test it to showcase it on the portfolio website. If you missed the last video on how to build this portfolio from scratch, check the link in the description. So first, let's get this up and running. I'll run npm start. The website is running locally, and now let's update this portfolio project 1 with information regarding our Logic app portfolio example. So first, let's change this navigation bar. In the navigation.js file, I'll just make this Logic app form responder. In the project section, I added an image to the portfolio folder underneath image. It's called Logic app form responder PNG. I created this in Canva. This is a simple image that just conveys I have a Logic app with Microsoft Forms that goes to an OpenAI action, which then goes to an email. Let's change the title here to Logic app form responder. We're only going to have one set of features, so I'll remove this so we can have the larger list. I want them to take up more space, so I'll change the columns for the styling for those particular items. Now let's actually change the data itself. Now if somebody comes to the Mason Stark website, they'll see this Logic app form responder, some information about it, some of its features, and they'll know that Mason Stark knows a little something about how to build a Logic app. But what's even cooler than just seeing information about it is actually being able to try it. So we're going to add a button that allows someone who comes to the Mason Stark website to actually try this themselves. This really showcases that Mason Stark knows what he's talking about because the action is working live. Going back to the project section, underneath this paragraph, before the features, we're going to add a button. It says try it out. Looks like we could use some margin, so we'll come to the styling. And in the styling page, we'll add a little bit of margin on the bottom for that button. Now because this project 01, we have this button which has a link to our form. This try out button should take a user directly to trying the form themselves so that they can put in their email and they can get knowledge on how to grow any fruit they choose. Let's give it a try. And here we have the response that was emailed to Mason Stark when we just filled that in to get bananas. Our first project is complete. Now let's add another project that uses Azure Functions and allows people to interact with your portfolio website. So here's the use case. In YouTube, in the description, there is timecode that can be used to create chapters to the video, where you can go to specific places in the video and makes it easier for the viewer to see specific parts of the video. However, creating this timecode can be a hassle because if you were to do it manually, you'd upload a video and then you'd watch the video and understand where all of the seconds are and then create this specific timecode format. It's kind of a pain. And it's a little bit easier when you have a tool like Premiere Pro, where you can add markers in throughout the video to the specific places where you want to have these chapters. I then have the ability to come to File and Export to export a markers file that then looks like this. And this is a pretty good start with the chapter titles and pretty close to the timecode that I'm looking for. So it just needs to get manipulated a little bit. Now let's look at the architecture. we're going to add in the functionality to upload a file to a container in an Azure storage account. At the same time, right after we upload that file, we have an Azure function that is going to start pulling the output container in that Azure storage account, looking for the edited file that has been manipulated. But almost simultaneously, when that blob is uploaded, our timecoder function will get triggered by that blob storage upload, and then it will output the manipulated file to the timecode output container. Our get download URL file will then pick that up and send that to masonstark.com, where the user can then download the updated file. So that's the overall flow for this solution. Now let's build it and add in the functionality to masonstark.com for this portfolio project. Just before we get started, if you want to follow along with this demo, you're going to need a few things. Visual Studio Code is the editor that we're using to edit masonstark.com and create our Azure functions. You're going to need an Azure account to create your Azure storage account and your Azure function that we're going to be using for the portfolio project added to the masonstark.com website. You're going to need the Azure CLI to help with authentication for your Azure Function Core Tools CLI, the Azure Function Core Tools CLI themselves, which will create our Azure functions, start them, publish them to Azure, and then also Node.js locally if you're creating JavaScript functions and following along exactly like the demo. Links to get started with each of these will be found in the description. Okay, to get started, I'm in a new resource group that I created. Now let's create our storage account. I'll come to the marketplace, type in storage account. I'll make sure I use the resource group I was just using, and I'll call this AIS Demo Func Store. Keep it ECUS, be a standard storage account, make this local, and review and create. The deployment is complete. Let's go to the resource and we'll create our first two containers. Going to containers, I'll add a container and we'll call it input timecode files. And then we'll create output timecode files. This is where we'll upload input timecode files, and then the output will be where the outputted blobs that have been manipulated will be. Next, let's jump to VS Code and create our Azure functions locally. In Visual Studio Code, let's create our function locally. Func function new. I'll select Node. I'll select JavaScript. The local files needed for a function app that can house functions are now being installed locally into my demo functions folder. In just a moment, we'll choose the template for our first function and how it will get triggered. Now we'll select our Azure Blob Storage trigger for our first function. We'll call it Demo AIS YouTube Timecoder. Now the function should have been created. Here it is. We have some standard template code right now. I'm going to go ahead and paste in the code that I've pre-created to actually create the conversion. All right, I've pasted this code in. Now a couple things we're going to want to keep in mind. We need a connection to our storage account that we created. So I'm going to create this connection in local settings.json by updating my Azure Web Job Storage and also creating a new connection with the demo AIS storage. We'll update this with our storage account access keys. So go into our access keys. This is where you can grab your connection string, hit show, and then copy, paste it in, and we should be set to test this. Now the way we're going to test this is by running this locally and then uploading a file to our storage account to trigger our function. So let's test this. We'll run func start and we'll upload a file to our storage account, which will trigger our local Azure function, and it should manipulate the file with the predefined logic that we've already added, and then output to the output container with the manipulated file. So this is running. Now let's go to our storage browser. Go to blob containers, input timecode, upload. I have a markers file that I outputted from Adobe Premiere already for a previous video. I'll upload this. Let's see if it was triggered. Looks like it was. Now let's check our output container. It looks like our output container has our outputted file. I can download this and take a look, and that worked, and this is much easier to copy and paste into a YouTube description. Now let's add the functionality to add this to the Mason Stark website. Let's stop this, and we're going to add another function. So I'll go Control-Shift-P, create function. We'll create an HTTP trigger. We'll call it getDownloadURL, and let's paste in the predefined code. Now for this, we are using Azure Blob Storage's SDK, so we are going to need to download that. So I'll make sure in my code, npm install Azure Blob Storage SDK. Real quick, all this Azure function does is that if there is a file that exists with the name that was uploaded in its edited state in the output container, then a download URL will be generated for the front end to allow a user to download it. So let's get this started and test it out. We'll go to func start. We'll grab the local URL in the browser. Let's put this in. Blob name equals, grab the name of the file that we uploaded without the edited part. And boom, there's our download URL. I can copy this, put this in another browser window, and boom, my file is downloaded. Now that these two functions are working, let's create our Azure function and then publish these two functions to that Azure function. All right, back in my resource group in the Azure portal, let's create an Azure function. I'll type in function app in the marketplace, create, I'll make it consumption. I'll make sure I'm still using the same resource group. I'll call this AIS demo function app. Windows, Node, East US, storage. Make sure to select the storage that we've been using, review and create. We'll come to our Visual Studio Code editor, and now let's publish this. Func Azure function app publish the name of the function app. All right, our functions have been uploaded to the Azure function app. Let's refresh and make sure that they're there, and they are. Next, let's add these to the Mason Stark website. I've opened up the Mason Stark website in my Visual Studio Code. Let's get this started, and we can see it in its current state, and then we'll start adding updates to add our timecode converter portfolio project. All right, this is what it looks like in its current state. We have our logic app form responder that we created previously. You can check out that video in the description. We're going to update this portfolio project 2 with information regarding our function app and the timecode converter. First, I have a file that I created that I'll add in here that will be used for our portfolio project icon. I created this in Canva. It represents the project because we output a markers.txt file from Premiere Pro. We make changes to it with an Azure function and ultimately use it then for a YouTube description. In the navigation, let's change project to YouTube timecoder. In the project 2 component file, we're going to add several changes. We'll add logic to upload the file, and also logic to call our Azure function, which gets the download URL. In our UI, let's add the new image, update some of these details, YouTube timecode converter. We'll add in the details for the buttons to upload a file and convert it, and also a button to download the converted file. We're going to add just a few features, not all. So I'll remove this. We'll add in changes to the data itself, talking about this project. And we'll update our styling so that our buttons look okay. To upload to Azure Blob Storage, we'll need the SDK for Blob Storage. So npm install Azure Blob Storage. A couple more things we need to add in here is, in order to upload to the Azure Blob Storage account, we need a shared access signature URL that allows the front end to temporarily upload to Azure Blob Storage. So let's create that now. We're going to do that in the Azure portal. All right, in the Azure portal within our Azure Storage account, let's go to our container. So we'll go to Storage Browser, Blob Containers. Once we're in our container list, these last three dots at the end, we'll hit Generate SAS, which is a shared access signature. We'll use this shared access signature in order to upload to the input timecode files container. We'll change the permissions to be create and write, and then we'll generate this token. Note when this token expires is when this will no longer work. So if you want this to work for a longer period of time on your portfolio website, you'll need to make the shared access signature longer in terms of how long it lasts. I'll copy this blob shared access signature URL and add it here in my code. Next, I'll need to make sure I add my function URL for the download URL function. Let's grab that from the function now. And under code and test, I'll get function URL. I'll select get function URL, and because I'm using anonymous as the auth level, I can use any of these. And I'll add this in. Now this is our website up and running with the changes we made, and we might think, hey, we have everything all set up, but there is one thing else we need to change. If I go to choose a file, add it, and then convert it, I get console errors about not being able to fetch. This is because CORS is not enabled, which is cross-origin resource sharing. To let this work, let's update our CORS settings in both our Azure Function and our Azure Storage account. In our Azure Storage account, we'll come to our settings, we'll go to resource sharing CORS, we'll add the allowed origin, select the methods that should be used, save this, and in the function app, let's come to the API CORS, and we'll allow for localhost. I had to remove that slash at the end. Let's make sure that slash is not here also. It needs to be exact without the slash on the end. And now let's give this another try. Add a file, convert it, and I'm able to download my converted file. Let's open this up and make sure it looks the way it's supposed to. And it does. To finalize these changes, let's commit the changes, open a new pull request, and merge it into our master branch. So I'll git add the changes that were made to this branch. And I'll push the changes to this branch. On GitHub, I see this notification that I just pushed this branch, and so I can compare it and make a pull request. I'll create a new pull request. Looking at the changed files in our pull request, let's merge it in. To make sure this works, let's add Mason Stark to the CORS, and we'll remove our local host. Save this. Make sure you have no slashes at the end of the URL. All right, we've made all our changes. Now let's refresh this, and boom, we have our new changes for our YouTube timecode converter portfolio project. We should now be able to give this a try. Choose a file. Once my file is selected, I will convert it, which does the upload. And now I'm able to download the file that got manipulated.
2 projects down, 1 more to go. Now this project is going to be an Azure AI agent solution. We'll have multiple Azure services involved, and you'll be able to send email reminders to yourself in the future by reminding yourself with an agent in the past. Let's dive in.
we'll be building an email reminder agent. The three core features for this agent are that it takes an email, a reminder message, and a future send time. It verifies the user email to make sure that they own the email they're asking to be reminded. And it schedules and sends an email at the future date that was specified earlier. This is the general architecture for our email reminder agent. Now let's see how some of this logic will work. The email verification flow works when a user asks the AI agent to send a reminder to them, and when they give their email to the agent will create a pending verification item to verify that person's email in Cosmos DB. They'll then send an email using the Azure Logic app to send an email to the user with a code that they can then use to verify their email. The user then takes that verification code, gives it to the AI agent, and then the AI agent will check the pending verifications to see if the codes match up. If they do, the email is verified and the reminder is scheduled. If the codes do not match up, then the reminder agent asks the user to re-put in the code. Reminders stored in the Cosmos DB database are constantly pulled by a timer-triggered Azure function, checking to see if emails are ready to be sent based on their date time. Once an email is ready to be sent, it will forward it to the Azure Logic app to send the scheduled email to the specific user. Now let's talk about the order that we plan to build this out. We'll kind of be going backwards by first starting with an Azure Logic app that can send an email using Outlook. Then we'll create a Cosmos DB database with our containers for pending verifications and reminders. We'll then create a timer-triggered Azure function that can check the reminders container in Cosmos DB, and when it's ready to send a specific reminder, it will forward it to the Azure Logic app to send that email. We'll then create our agent using Visual Studio Code at first, and when we're ready then to deploy our agent, we'll create a Docker image, push it to a container registry, which will then deploy to an Azure Container app, both the front-end chat interface and our agent in the cloud. If you want to follow along this demo step by step, you'll need a few different tools. Visual Studio Code for building your AI agent and your Azure function, an Azure account for deploying your Azure resources, the Azure CLI for deploying to your container registry and authenticating for your Azure Function Core tools, the Azure Function Core Tools CLI, which we'll use for interacting with our Azure function. JavaScript is the programming language I'll be using for this solution, so you'll want Node.js installed locally. I use Postman for local API testing. You could use this as well, or any other API testing tool you prefer. And Docker Desktop to build our Docker images that will push to our container registry and then deploy to Azure Container Apps. Anytime I'm building something new, I always like to start in a new, fresh resource group. So I have this new resource group, and let's start by creating our Azure Logic app. We'll go to the marketplace, type Logic apps. Find Logic app, start creating our Logic app now. I'll choose consumption, make this quick and easy. The Logic app name, we'll call it LA AIS Demo Reminder Agent. Choose the same region as my resource group. I won't enable log analytics. Leave the defaults and create our Logic app. Once our deployment is complete, we'll go to our Logic app. Let's get started building this out. First, we're going to add a trigger. This will be by a request because our Azure function timer trigger is going to send a HTTP request to our Logic app, and also our agent later, when we're sending verifications, will also send an HTTP request to our Logic app. The URL is going to be generated when we save it. Let's give it a sample payload so that it has a JSON schema to go off of. When we make requests to it, we're simply going to give it a user email, a subject, and a body. And this is what we will want to be emailed for our reminders and our email verifications. Now let's add the capability to send an email. I'll go to Outlook. And I want to do Office 365 because that is the type of account that I have. Find, send an email. I'll need to sign in. Now that we have our connection created for sending an email to Outlook, in the To section, I will use a dynamic variable, the user email that comes from the HTTP request, the subject, which also comes from it, and the body. And make sure here there's a large body and small body. We want small body. Large body would have the entire body from the HTTP request. Small body is the specific JSON variable body that we've specified in our request. We'll leave the rest of these defaults. Now let's save this and we're going to test it. We'll run with a payload. And we're going to give it our example payload. HTTP status 202. So it looks like it worked. Let's check our Mason Stark email to see if we got the email. And we did. Now that our Logic app is working, let's go create a Cosmos DB database. So we'll go back to our resource group, go to create, search Cosmos in the marketplace. Find our Azure service, Cosmos DB, start creating it. We have a couple options for Cosmos DB. We're going to choose the NoSQL because we're not using any APIs related to MongoDB. Then we're going to try and keep this easy. We'll use learning as our workload type. This is cheapest and it's just quick and easy for beginners. We'll make sure we're using our resource group. We'll enter our name, Cosmos. We'll not enable availability zones. I can't choose East US, so I'll choose Central US. I'm going to choose serverless because I only want to pay for the traffic that's coming in and out of my Cosmos DB database. And then I will review and create my Cosmos DB database. Once your Cosmos DB database is complete, we'll then go to our Data Explorer. You can learn about Cosmos DB from this video. We won't do that. I'll start by creating a new container. I have to create a new database first. We'll call this DB Agent Reminders. We'll make our first container pending verifications. The partition key, which we'll use to organize our data, we'll make it email because that is the key feature for pending verifications, and also will be for our reminders container. Then we'll create. All right, now that we see or have our pending verifications container, let's create another container for our reminder emails. We'll use the existing database that we just built, and this one will just be reminders. Partition key will also be email, and then we'll create it. Now our Azure Cosmos DB containers are set up, and we're gonna go build our Azure function in just a moment. And our timer trigger Azure function is gonna need some data to test. So let's add an item to our reminders container so that our Azure function has something to go off of to test with. So we'll add some sample data in. Which will be a reminder email to Mason Stark to bake a cake. With subject reminder from an agent. We'll make the send time. Well, we'll leave the send time because it's going to be the time before today, so that the email will be sent as soon as the Azure function picks up on it. Cosmos DB adds some metadata after we save it. Now let's go create our Azure function. I'm in Visual Studio Code in a new folder I created called Demo Agent Reminder. Let's create a new folder for our functions. Then we'll go Control-Shift-P. And with the Azure Functions extension installed locally, I will create a function. We'll create it in our current folder, and I'll end up moving the files into the functions folder. We'll create it in JavaScript. It'll be a timer trigger. We'll call this func AIS demo agent reminder. We'll leave the defaults for now and create our function. Now the first thing we'll do is take all these files and add them under the functions folder. Now let's test our function. I'm going to make it trigger every 1 minute so we can just see it working real quick. We're going to need to have a storage account or a storage emulator locally. I'll prefer to create a storage account in Azure that I'll just add here. So let's create a storage account so that it can start running properly and we can see it run locally first, and then we will add in the functionality to connect with Cosmos DB. We'll go to our resource group, create storage account, create a storage account, make sure we're in the right resource group, storage account, AIS, oh, no dashes in storage accounts, demo agent reminder, leave it East US, be a general blob storage. Standard, we'll make this local, review and create. In our new storage account, we'll come to access keys. We'll grab our connection string. Note, you should never share these connection strings with anyone publicly, but I'm removing these resources before this video is published, so it's okay. Once we have our connection string there, I'll save this. Now our function should work properly. And now let's try our function. Func start is the command to use with the Azure Function Core Tools CLI. Our timer trigger is now running locally, and we should see timer function processed request every minute. I'll speed this up a bit so we don't have to wait that whole time. And we see our functions working. This is great. Let's stop this. Now let's update our Azure function so that it interacts with Cosmos DB, checking when there is a reminder that is ready to send, and also sending a request to the Logic app so that it can send an email. I'll add in all this logic. Now let's take a look at what this is doing. We bring in our Cosmos DB library, We'll rename this to the name of the function, reminder. This will work every minute. The function will get triggered. The Cosmos DB client will then be created. We'll connect to our database, connect to our container reminders. We'll query to see if there are any reminders that have not been sent and where their time is before right now. If there are reminders, then each one will be looked at, and we will send a request to our Logic app endpoint with the user email, the subject, and the body, just like our Logic app needs. We'll then mark the reminder item in Cosmos DB that it was sent. Now for this to work, we'll need to add some environment variables and our Cosmos DB package. Let's first install our Cosmos DB package. That's installed. Now let's take a look at these endpoints and add them to our local settings.json file. I'll let GitHub Copilot help me out with that a bit. Cosmos DB key, gotta make sure that it's correct. AI agents are never perfect. The naming is right. Let's add this. Logic app environment variable. Now we're gonna need our Cosmos DB endpoint, key, and our Logic app endpoint. Just double check, that's all we need. 1, 2, 3, yes it is. Okay, let's populate these. Go to our resource group. First grab our Logic app endpoint. For our Logic app, we'll go to Logic app designer. We'll grab when HTTP request is received, and we have this HTTP URL. This is what we need. Add the endpoint in. Going back to our resource group. Let's go to Cosmos, where we'll go to keys. We'll grab the URI, which is our endpoint. And then our key. These secrets should be kept secret, and they should never be public. The only reason I'm showing them here is for demonstration purposes, because I'll be deleting all of these resources before you see this video. With all these environment variables set up, let's give this a try. We'll check Cosmos DB first. We want to make sure that we have an item in the reminders section that will be grabbed for this. Go into items. We still have, yes, sent false with the send time before, so we should get this item sent to test this. Long start. And it looks like our email was sent right away. Checking our email, and we see reminder to bake a cake. Now that our Azure function timer trigger is set up properly, let's deploy it to Azure. Stop this. Let's go to our resource group. We'll create an Azure function app. Functions exist in function apps. We'll make it consumption. We only want to pay based on the requests that are actually made. We'll call this func app as demo agent reminder. Runtime and node, make this East US. And the storage, we want to make sure the storage is using the storage that we just created. This is it. And then we'll review and create. We'll go to our Azure Function app. And the first thing we're going to do is add in the environment variables that we need to use for our function app. So just like we have our local settings.json, let's add in the environment variables we'll need for our function app to work before we publish it. Our environment variables are in our function app. Let's add another item to our Cosmos DB database, and then we'll deploy our function that we have locally to our function app, and we'll watch it work right away. Go to our resource group, Cosmos DB, go to Data Explorer, go to Reminders, add a new item. We'll say bake a cake. Again, a couple exclamation points. We'll save this. So now we have an item that we see was sent true, and the item we just added sent false. This will be bake a cake again, which should be picked up by your Azure function in the cloud once we deploy this Azure function. So now let's publish this Azure function. We're going to need the name of the function to do that. And we'll use the Azure Function Core Tools CLI to publish this. Now we'll publish it using func Azure Function App publish name of the function app. And as soon as this is deployed, we're also going to start the log stream using func Azure Function App log stream and then the name of the function to see if we can see the logs for our item that we just added to Cosmos DB to know that our function app in the cloud is working. All right, deployed successfully. And then let's run func Azure Function App log stream, name of the function app. Hopefully we can pick up the logs before the item is sent. And we do. We can see our email that was just sent to bake a cake again. So now we know our Azure function in the cloud is working. Now that we have our Azure function built, our Cosmos DB database deployed, and our Logic app able to send emails, it's time to start building our agent. Now that we're ready to start building our agent, let's talk about the development lifecycle that will follow to build this agent. First, we'll develop this agent by building it locally, and we'll just test it using the CLI built into Visual Studio Code, although you could use any terminal to test it. When we're ready and like the way it's working, we can expose an HTTP endpoint so that it acts as a backend solution and a front-end solution can easily call it as the endpoint. Then we'll containerize our agent by building a Docker image that we can then test and see our agent is working properly in a container. And once we like the way it's working in a container, we'll then deploy that container image for our agent to a container registry and then to Azure Container Apps. Now, to start building our agent, we're going to need a resource with a deployed LLM that will act as the brains for our agent in Azure AI Foundry. So first, let's do that. I'm in Azure AI Foundry, which you can get to with ai.azure.com. We'll need to create an Azure AI Foundry project and a deployed base model that will be the brains for our AI agent. So let's do that now. We'll create a new AI Foundry resource. We'll call this project, call this AIF, AIS for AI Foundry, demo agent reminder, which will be that resource. Make sure we choose the same resource group so we can keep this all in the same place. Resource group AIS demo reminder agent. Put this in East US, which is where our resource group is, and we'll create this project. Our project is created. Now let's deploy our base model for our agent. We'll go to the model catalog and we'll choose a smaller model. We'll use GPT 4o mini. I know this is a powerful model and it's not too expensive. Let's create a deployment for this. Agent reminder. We'll add an agent reminder to the end of the deployment name. Leave the defaults and deploy it. Our model is deployed. Now let's start building this out in Visual Studio Code. We'll create a directory called agent. Enter it. And then we'll run an npm init to install a package.json file. We'll leave all the defaults. And now we have a package.json file which we'll use to install our packages for our project for our agent. I'm going to change this to type module so that we can use import statements. Now let's start with an agent file, agent.js. We'll add in this base code for our agent. We'll also add index.js to work with the CLI. Index.js just uses the standard input and output and calls our run agent function, which is what interacts with our agent. Our agent file is just a giant function that calls run agent with input and an optional thread ID to maintain the thread history. We're going to need some environment variables added here. So let's create a .env file. We'll start with these. Our agent will need a project endpoint, which is the endpoint for our AI Foundry resource that has our model. We'll need the name of the model deployment that we made, which we'll add. And these other three environment variables would be associated with a service principal, which is an identity in Azure that we'll create so that we can interact with our Azure AI Foundry resources and the resources within our resource group. So we'll be creating that in just a moment as well. First, let's grab our project endpoint. In Azure AI Foundry, let's go to the playground for this model. We want to open up the agents playground. We can go to the view code section and see the endpoint that's being used in the view code section. This will be the endpoint that we want to use for our project endpoint. You can also see this endpoint in the Overview tab of your project in Azure AI Foundry. We'll need the name of our deployed model. And just before we create an Azure Service Principal, let's install the packages that we're going to need for our solution. I'll run npm install our agents package, a core utility package, Cosmos package, an identity package, and a .env and an express package. Our packages have been added. Now let's create a service principal in Azure for our agent so that our agent has authorization to access our Azure AI Foundry resource and our resource group within Azure. Back in Azure, I'll go to App Registrations. I'll create a new registration and we'll call it App Reg AS Demo Reminder Agent. Only I'll be using this, so I'll leave it as the default in my account. We won't use a redirect URI and we'll register this application. Now I've registered my app, so I have an app registration. I have a client ID that I'll use for my client ID. I have a tenant ID that I'll use. And now I need a client secret. So let's go over certificates and secrets. We'll create a new secret. We'll call this secret demo agent reminder. It's valid for 6 months, although again, I will be deleting it before you see this video. Copy this value because if you don't copy it right now, you won't be able to see it again. So always make sure you copy the value as soon as you create the secret in the portal like this. Again, these secrets should not be shared publicly. I'm only showing them because I'll be deleting these resources by the time you see this video. I have to keep saying it because it's super important. But now in Azure, all we have is an app registration with a secret. Let's assign it some permissions. Back in our resource group, we'll go to the access control or the IAM resources. And now let's create a role assignment for our app registration. We'll give it a privileged administrator role, contributor. Next. Now let's give it the contributor role to our app registration, which will create a service principal. Select members, app reg, choose our app registration. And now this will create a service principal. And we can see that we have the service principal with contributor level access in our resource group. Next, in the resource group, let's go to our Azure AI Foundry resource, and we want to assign an Azure AI Project Manager role to our app registration for this resource. This will give it more ability to interact with our agent. Azure AI Project Manager. Select our app registration and create the service principal. And we can see the service principal here as well. Now that we have our packages installed, our environment variables populated, let's take a look at how this agent works, and then we'll give it a test. We import our packages, some environment variables, create an agent's client, and then we have our run agent function. This run agent function first starts by creating an agent if an agent ID isn't specified to use an existing agent. Then there are some instructions for this agent, which just tells it to craft an email, which will be sent back to the user when it asks for a reminder. This is what we'll use and we'll start with. We'll be updating this as we go. A thread is created to maintain a conversation history. It will use an existing thread if specified. A new message is created based on the input given to the run agent function. The agent is run where every second its status is checked. Right now, it's just seeing if it needs anything to answer the question of the user. And right now we have no tools, so it should just respond right away. But later, we'll have a requires action status where our agent will wait until tools are called in order to get back to the user. The history, the latest message, and the thread ID are returned from this function. And in our package.json, let's create a starting command. We'll call it CLI node index.js. So this will call it index.js, allowing us to interact on the CLI. So let's give this a try. Fingers crossed, npm run CLI. What can you do? Our agent is created, a thread is created, a message is created, a run is created, status in progress, and then status complete. Our agent responds saying it can help us schedule reminder emails to be sent at a future date. So now this is working properly. Now let's update its functionality. I'll stop this. Let's add in a server.js file so we can host a HTTP endpoint. We'll add in this code, uses an express server, has an endpoint called chat, and calls our run agent function. To test this, I'll use Postman, but you can use any API testing tool. First, let's go to package.json to create a start command, and we'll call this one start, and it'll be called node server.js. Now let's start this up locally. npm start. Our server is running on port 3000, so we should now be able to go to localhost 3000. And our endpoint takes a message and optionally a thread ID to maintain thread history. I've opened up my local Postman editor, and I have a base URL for HTTP localhost 3000/chat because of our endpoint that is running. I'll just message it, what can you do? And we have our response from our agent saying it can help us schedule reminders and the history of the conversation. So now this is working properly as well. Now let's add some sophistication by adding in some tools. The tools we'll add will be a handful of functions that the agent will use in order to take actions on our behalf. So for our email reminder agent to work, we're going to need a handful of different functions. We're going to need a tool that can capture the current time, current date and time. We're going to need a function that can send a verification code. We'll need a function that can verify a code. And we'll need a function to schedule a reminder once that code is verified. To get started, we'll create a tools folder. I'll create a file called function tool executor.js. I'll paste in some code. And this function tool executor will be used by our agent to help our agent call the functions as tools. There's only one function in here right now, this get current date time. Up here in this function tools array is just the parameters in the description for it. Gets the current date and time is the description. This description is important because it tells our agent how and when this function should be called. So if I ask for the agent to remind me to do something in 5 minutes, it has to know the current time in order to know what is the current time plus 5 minutes from now. So the agent will call this function to get the current date and time. The current function itself is this get current date time function, and it's referenced in this function tools array. The invoke tool method is used by the agent to actually call the function that it's using as the tools, and it passes in any parameters that it needs to. And the get function definitions method is used by our agent to get those definitions for each function so that it knows when and how to use them. Going back to the agent file, let's import our function tool executor. We'll create a new instance of our function tool executor. We'll get the function tool definitions, and then we'll add these functions in as tools for our agent. Now, when the agent recognizes that a tool should be used, it will change its status to requires action. And let's add in some logic so that our agent knows how to deal with the status of required action. This logic helps our agent determine what type of tool should be used, then what type of function tool should be used, invokes that function with the right parameters, if any, and then uses the output from that function tool, gives it back to the agent as context, and then continues the agent run and allows the agent to then respond or determine what the next status is based on that tool. We should now have everything set up so that we can get the current date and time using our function. So let's make sure we're in the right place. And then we'll call npm run CLI, because we'll try this locally first. Let's ask it, what time is it? And we can see the agent made a call to the function tool to get the current date time. And it determined this because it understood the user's intent, asking what time it was, knowing it would need to try to determine what time it was. And it didn't want to guess. So it took a look at its tool definitions, saw that it had the get current date time function, which gets the current date and time, decided to call that, and use the output to help it make its response to us. Now that we created a tool to get the current date and time, let's add in functionality to send a verification code. This way, when there's somebody who has an email and they want to get reminders sent to them in the future, they have to verify their email first, and they can't just send reminder emails at any time to any email they choose. So back in the function tool executor, we're going to need to use Azure Cosmos for this, because we'll be creating a new pending verification as part of this function. We'll add in a new function definition. Send email verification. It sends a verification email to the user's email address. It takes an email and we'll add that as part of the function. The function itself, we'll add in our send email verification will take a parameter of email, which the agent should pass in based on our tool function definition. It'll check to see if the email is valid. A Cosmos DB client will be created. A verification code will be created. And the item with the 6-digit verification code will be created and added to Cosmos DB. After that, we'll call our logic app endpoint to email the 6-digit code to the user so that they can then input it into the agent to prove that their email is indeed the one they added and asked to be reminded. I'll save this. We'll update the system message. You are a reminder agent that schedules emails to be sent to the future to a user. And we'll say, you send an email verification. You send an email verification when a user asks you to remind them of something and gives you their email. Now we need to add in our Cosmos DB endpoint, key, and logic app endpoint. Let's copy these over from our function local settings.json file. All right, now we'll start this, run npm run CLI, and we're going to ask it to give us a reminder with an email, and then we'll check to see if we get an email verification. Please remind me to take out the trash in 5 minutes. My email is Mason Stark. Let's see if we get an email verification. Looks like I can see the output sent an email verification. At least it says it does. Now let's check to see our email. And I can see the verification code from my agent. So that's working as well. Great. Next, we need a function to verify the code, which will call Cosmos DB based on the code that the user then inputs after they get the code from their email. So going back to our functions, we'll add in another tool definition. This function tells our agent that it verifies the email using the 6-digit code. So when the user then puts in the 6-digit code, the agent should know to respond. The first thing is to verify that code using this function tool. And the way this verify email with 6-digit code works is that the agent already knows the email from it being given previously to send the email verification. So the agent has the email in context and also gets the verification code when the user puts it in. It first checks to make sure the email and the verification code are valid, creates a Cosmos DB client, which then checks the pending verifications container to see if the verification code with that email are inside the container and are currently pending. If they are, and it comes back that it exists and that the code was not incorrect, then the pending verification item will be changed from status pending to completed, and we'll return to the agent info saying that the verification was successful. If it was not successful and the verification fails, we'll return to the agent that the verification failed and that the agent should ask for the code again. Now let's give this a try. So we'll start this over. We'll start our agent again. npm run CLI. Remind me to take out the trash in 6 minutes. My email is masonstark211@outlook.com. Now what we're going to do is we're going to get that verification code from the email that it sends. Then we're going to put that back in here, and it should use the verify with 6-digit code function after I put it in. All right, here's the verification code. Let's grab this. We'll input it into our CLI. And we can see that the verification was complete. Now we've made a tool to get the current date and time. We've made a tool to send an email verification code. We've made a tool to verify that code. Now let's add a tool to actually schedule the reminder. So going back to our function tool executor, we'll create another definition for our function tool executor. This is our schedule reminder function. This actually schedules a reminder email after the code is verified. It takes the email, reminder, and the reminder time, which should all be within the context window for the agent. And then we'll add the function itself. And the way the schedule reminder function works is it takes the parameters that the agent gave it. It first checks to make sure those parameters are valid. Then it uses a Cosmos DB client to create a reminder item, which it then puts in the container for reminders. This is when the Azure Function Timer Trigger will check the Cosmos DB reminders container to see all the items that are ready to be sent based on that send time, and will send them to the email that it needs to when the current time is greater than the send time. All right, now we have all of our tools in. Let's give this a try. I'll say remind me to take out the trash 1 minute from now. My email is Mason Stark. Now it should want to verify my email. We'll verify it with the 6-digit code. After we've done that, it should send us a reminder email in about 1 minute. Let's grab the code it just sent us. Looks like there was an error. Oh, I think I forgot to save my function tool executor. And actually, this reminds me, I do want to update my system function to make it super clear as to how to work. And I've played around with this system function in the past already, giving it strict instructions. You are a reminder agent that schedules emails to be sent at a future date for a user. You must follow this strict workflow. 1, you ask for the user's email and reminder details. 2, you call send email verification and you wait for the user to provide the code. 3, you call a verify email with 6-digit code with the code. Only if the tool output contains verified true, proceed. 4, if code verified is false, ask for the code again and do not schedule the reminder. 5, only after code is verified, call schedule reminder. Never call schedule reminder before the code is verified. When you call schedule reminder, you craft a pretty email in HTML format for the reminder and schedule it to be sent at the specified time. You always get the current date and time to ensure you send at the correct time. Giving instructions like this help our agent understand the actions it's supposed to take in the right order so that we don't send an email verification or a scheduled reminder when we're not supposed to. So now with everything saved, let's try this again. Remind me to take out the trash 1 minute from now. From now, my email is Mason Stark. We see email verification was sent. Let's check our email. We see the new code. Let's grab this, put it in, proceed to schedule the reminder. Looks like it was. And the agent says, your reminder to take out the trash has been scheduled successfully. You will receive the email at the specific time. Thank you. And in just a few moments, we should see that email. And here's our reminder to take out the trash that we just received. Now that we know this is working with the CLI, let's test this one more time with the HTTP endpoint. And then we'll move on to containerizing our agent. We'll run npm start. We are in our functions folder. Let's move to our other terminal. Stop this. npm start in our agent folder. We're running on port 3000. Let's go to Postman. We'll start by saying, my name is Mason. Could you please send a reminder to pick up the dry cleaning? Please remind me 5 minutes from now. We'll say 2 minutes from now. We'll say 1 minute from now. My email is Mason Stark. And I don't have a thread ID yet, but I will add the thread ID back in for when I want to respond and make sure I'm going back and forth to the same thread. We have our response. It says, I've sent a verification code to your email. Please check your inbox and provide it to me. So first we're going to grab this thread ID so that when we send another request, it knows that we are having the same conversation. So let's go to this provide 6-digit code. We'll replace this thread ID with the thread ID that we just got. Let's go get the code. In fact, actually, let's start to just see this code not work. It should break and say, hey, that's not the right code. Please send a new code. And it does come back saying the verification code you provided is incorrect. Please check your email again for the verification code and provide the correct 6-digit code. So now we'll check our email. We'll grab the correct code. We'll come back to Postman. We will provide the correct code. And we'll send this. And it says, I've successfully scheduled a reminder for you to pick up the dry cleaning. You will receive the email reminder shortly. If you need anything else, feel free to ask. In just a moment then, we should get that email. And there's our reminder from the reminder agent to pick up the dry cleaning. At this point, our agent is doing everything it needs to for our email reminder process. And now we want to containerize it so we can deploy it to production in Azure. So the first thing we'll do is we'll add a new file, a Docker file, so that we can containerize our agent. Let's add a Docker file. We'll add the instructions to build the image. I'll start up Docker Desktop. First we'll do Docker PS, make sure this is working. Looks like maybe it's still not running. It was still starting up. So now it should be working. There we go. We'll also add a .docker ignore file so that we don't pick up our env file or our node modules in our image. Now we'll build our image. Say docker build -t demo backend agent reminder. Now I can check Docker images. See our demo backend agent reminder. Now let's give this Docker image a try by spinning up a container. Let's make sure we're in the same place where our .env file is. Now we'll run docker run --env file. Use the env file that we have currently. I'll map this to port 3000 for demo agent backend agent reminder. I think I spelled that wrong. It's demo backend agent reminder. So we're running on port 3000. It should be all the same commands we just did in Postman. So we'll say pick up the dry clean. We'll say pick up the carryout. Now this is interesting. So it didn't work. So something was off. And I just remembered the .env file, when it comes to running in the Docker containers, the .env file cannot have these quotes around it for the environment variables. Frankly, I forget why. I think it has to do with the way the values are mapped as environment variables when they're loaded into the environment by the Docker runtime. So all these quotes gone from the env file. We'll try this again. Run in that Docker file. I think we have to stop our Docker container currently. So we currently have our Docker file running. Let's run docker stop. Running docker stop, and then just putting in the first two numbers of the container ID. So it should pick up the running container and then stop it. It gives the two numbers of the container ID that it just stopped. Now I can run docker ps, see that there should be no running containers, and now I'll start running that container again. Now it should use the env file without the quotes around the values, and now it should map properly and be able to make a request in Postman. And there we go. So that time it worked. Said it is going to send a email verification. Let's get that email verification code. Go back to Postman. Provide that 6-digit code. We also need to grab that thread ID. Update the thread ID and the code and send this. Your reminder to pick up the carryout has been scheduled for 1 minute from now. You'll receive an email shortly. All right, and then we should get an email any second now. There's our reminder about picking up the carryout. So we now know that our containerized agent is working properly. All right, our email reminder agent is now up and running locally in a container. Let's add a container for a front-end chat-like interface so that we can interact with our agent on a web browser, which will eventually then be in an Azure Container app in Azure. I already know that I have a local container running for this, so I'll get this up and running using docker run. Docker run, import it to the 8080. Now let's go to a web browser. We'll go to localhost 8080. And we have our chat interface. Now let's say, what can you do? Oh, there's an issue. Let's see, what is the issue? What is the issue? We need to install cores on the back end. So let's go take a look at our code for our agent. Let's add in cores. We'll need to rebuild our agent. I'll stop the current agent. Let's see, our backend agent is container ID F6. And then we'll run docker build. Tag this demo agent reminder 02. Then docker run. With the port going to 3000, demo agent reminder 02. Interesting. Did we not install cores earlier? I guess we did not. Let's install cores. We'll build this again. We'll call it image demo agent reminder 03. We'll make sure there's nothing running, only the front end running. That's good. All right, then let's run this a new version. Let's run this Docker image 03. So running on port 3000, cores should be enabled. Now let's run this. All right, now let's give this a try. What can you do? We'll say, remind me to turn off the lights in my home in 1 minute. We'll pretend it's late at night and we've got to turn the lights off before we go to bed. My email is Mason Stark. It should ask us to give it the verification code. Send the verification code. Let's check our email. There it is. Copy this over. Your reminder to turn off the lights in your home has been successfully scheduled. You'll receive an email to my email in 1 minute from now. Thank you. And let's check the email. A minute from now, we should have it. And here's our email for our reminder agent to turn off the lights in our home. We've gone into detail on how to build this agent step by step. And if you want to create your own front end that interacts with this agent, you just need to have a front end that sends a request with a message and optionally a thread ID, and then is able to receive a response with the thread ID, the latest message from the agent, and a history of the conversation and context. If you want to get access to the code that I used for the front-end chat interface, you can find it in my online school community at school.com/Microsoft-Azure. There's also a link in the description. Now our next step is to create an Azure Container Registry where we can push our container images to and then deploy them to Azure Container Apps. Let's create our Azure Container Registry in Azure now. So we'll go to our resource group. We'll go to create. We'll create a container registry. Create. We'll make sure we're in the right resource group. And we'll call this Azure Container Registry, AIS. demo agent reminder. I'll leave it as East US. I'll leave this as unsecure, which doesn't actually mean it's unsecure. It just means that it's not going to have a hash at the end. I could have a hash in here, but I think it's just easier to just not have it. So I'll use it the unsecure setting, which is still secure for reference. I'll choose the basic pricing plan and leave the rest and create. I'll go to my resource. And it's pretty easy to get started by hitting the push an image, where it'll tell us how we can log in. I know that I can use this Azure CLI command to log in. I'm just going to need the resource group also. So in my CLI, I'll stop this. And we'll say ACR, login with the name of the Azure Container Registry. Let's grab the name of the resource group. Login succeeded. Now we need to change the name of our container images. We can go here to push an image, and you can see you want to change the name of the image with Docker tag to have the same name as my container registry, and then the type of tag that I want to push. So I'll copy this. And we'll do Docker images. And I know we'll push the demo agent reminder 03. It's going to be Docker tag, the name of the image, and we're tagging it with the name of the container registry and then the image tag at the end. Now we're going to push that new image to our container registry, since we're already logged in to the Azure Container Registry locally. The push should work properly. Now we can check our container registry, go to repositories, and see our demo backend agent. I'll wait to push up the front-end image until I have our demo backend agent image running in an Azure Container App with a URL for that backend Azure Container App that will be hard-coded into the front-end image that gets pushed to our Azure Container Registry and then to our front-end Azure Container App. Next, let's create our Azure Container App. So back in our resource group, we'll go to Create. We'll search Container App. Go to Container App, Create. We'll make sure to use the proper resource group. We'll call this ACA, AIS, Demo, Agent, Reminder. Create a new ACA env, Demo, AIS, Agent Reminder solution. Create it. Azure Container Apps need to be inside a Container Apps environment, so that's what we're creating now. Now let's move on to creating our container. Our container will pull from an Azure Container Registry. We'll select the registry. Make sure to select the right one. Our demo backend agent image. We'll select the latest image. And then we do need to add in our environment variables. So let's add in each of these. finally, our logic apps endpoint to be able to send emails. Go to ingress, make sure this is enabled, accept traffic from anywhere, because even though our front end will be inside an Azure Container App within the same Azure Container App environment, it's still making calls from our web browser and we'll need to access the Azure Container App agent in the backend. Then let's review and create this Azure Container App. Once deployed, we'll grab the backend URL, update our postman locally, and give our backend agent in an Azure Container App a try using the full workflow. Our resource is done being created. Let's go to our Azure Container App. We should now be able to test our application URL for the Azure Container App that is running our email reminder agent. I've updated the base URL with my URL for my Azure Container App agent. Now let's ask, my name is Mason, could you please send me a reminder to take the cookies out of the oven? Please remind me in 1 minute. My email is masonstark211. I'll send this. And that worked. I have a new thread ID. I will go to add in this thread ID, and then we'll go get the code. That should have just came to my email. There it is. In Postman, I'll add this in here. And I'll send it. Your reminder has been successfully scheduled. And then in just a few minutes, we should get that email reminder to take the cookies out of the oven. And there is our email to not forget to take the cookies out of the oven. Now we need to push our front end image for the chat interface to our Azure Container Registry. I called it demo chat interface 01. So let's retag that using our Azure Container Registry. So go back to our Azure Container Registry. Grab the name of our Azure Container Registry. And then re-add the name of our demo chat interface 01. And then we'll push this to our Azure Container Registry. Push. All right, now let's check our Container Registry repositories, and we see we have our demo chat interface 01. Great. Now let's create an Azure Container App for that image. Go to Overview, back to our resource group. We'll create another container app, Container App. Create another container app. We'll create this container app, making sure to be in the same resource group. We'll call this ACA AIS demo agent reminder front end. It'll be a container image, East US. We'll make sure to choose the same container app environment we were using before. Go to the container. It'll be from Azure Container Registry. Choose the container registry we've been using. Choose our chat interface, the latest tag, and nothing else changes. The environment variable was built in. Go to ingress, enable it, accept traffic from anywhere. Go back to basics. Must be consist of lowercase. Oh, it's too long. Our name is too long. Let's say remind front. Yeah. All right, review and create. And we'll create. Our Azure Container App for the chat interface is deployed. Now, in order for the front end chat interface to interact with the back end Azure Container App agent, we'll need to add our URL for our front end to the CORS policy for our back end Azure Container App. So let's go to our back end Container App. We'll come down to CORS. We'll add this as an allowed origin and apply it. Once this CORS policy is in place, we should be able to go to our front end URL and test our agent. We'll copy this, and in a browser, go to our front end URL. And actually, this is the back end, so we'll go to our resource group again. We'll go to the front end Azure Container App. We'll grab that URL, and in a web browser, we'll go to the Azure Container App that's running our chat bot interface. All right, now we're ready to test the whole workflow in our chat interface. We'll start by saying, what can you do? Make sure that our agent is still working. Tells us that it can schedule emails. We'll say, remind me to take the cookies out of the oven in 1 minute. My email is Mason Stark. Sent a verification email to your address. Please check it. Provide the 6-digit code. Let's check our email. We have our 6-digit code. Copy this over. Put it in. Great, and it looks like our reminder email is scheduled. And in a minute, we should get that reminder email sent to us. And there's our reminder to take the cookies out of the oven, so we won't forget. We've completed the architecture for our email reminder agent. Now let's add our agent to our Mason Stark portfolio website example so that we can showcase our agent to anyone who might see our masonstark.com website. I'm in Visual Studio Code with our Mason Stark website repo up. And now let's make a new branch for the changes we're about to make to the repo. Git checkout -b for creating a new branch, and we'll call it demo AI agent reminder. Now let's start this, and we're going to start making changes to the Mason Stark website. Once we've made our changes, we'll push the new changes to this branch, open up a pull request, and merge it into the master. And right now we can see that it just has the first two portfolio projects that we created. Now let's update this portfolio project 3 with our email reminder agent. So the first thing we'll do is in public images, we'll add our portfolio image. I created this image in Canva, and it gives a general idea of what this is doing, where we can say remind me in 5 days. It hits an Azure Container App, uses Azure AI Foundry, Azure Cosmos DB, and Azure Function, Azure Logic Apps. and then it sends a scheduled email on time. This kind of just gives a quick visual flow on what this portfolio project is doing for someone who's going to try to read this and take a look at what's going on and what resources are being used. Again, this is all about showcasing the portfolio project and what we know by showing the agent off. Next, let's go into our components in our source file. We'll go to project, where we'll update the title to email reminder agent. Let's also change this in the navigation, or instead of project 3, we'll call it email reminder agent. In project 3, now let's update our image. We'll add a button to allow people to try out our function. And let's add in our URL for the front end. In Azure, we'll grab our URL for our Azure Container App front end. Come back, make this the hyperlink, so that if somebody were to go to this new link, they would pull up our agent. They would pull up our chat interface to our agent, thus being able to use it in real time. Back to how we're going to change this. Again, we're only going to have one list of features, so we'll remove this and update the column lengths of these two classes. Now let's update the data. We'll add a bunch of features in there. Finally, let's update our button so that it has a little bit more space. Great. Now looking at this, this is what our portfolio project number 3, our email reminder agent, looks like on our portfolio website. We have our features, our small description, our title, an image, and the ability to try this out by going to our chat interface link and interacting with our late agent. Now all that's left is to complete the process of saving these changes, pushing them to our GitHub page, and merging a new pull request into the master branch. So I'll add these changes. I'll add a commitment message. And then I'll git push, origin demo. Oh, I didn't spell origin right. I push those changes. And I'll go to GitHub. On GitHub, I'll see that I just pushed to this branch, so I can compare and open up a new pull request. I'm happy with the default. Add email reminder agent, create pull request. Some checks will occur, and then I can see the changes that I made. Once everything looks good, we'll merge it into the master branch. This should update the CI/CD for masonstark.com, and we should have our updated masonstark.com with our email reminder agent. All checks have passed. Let's merge in this pull request. We can go to our GitHub Actions and see that the master branch has a new CI/CD action that is being ran. Once this is complete, then we should have our masonstark.com updated. If I go to Mason Stark right now, I'll see that it still shows Portfolio Project 3. But once this is done, we'll be able to update this and see our email reminder agent added to masonstark.com. The deployment to production was complete. Now let's update our Mason Stark website. And we can now see our email reminder agent is showing off here. Or we can go to try it out and see our chat interface. Fantastic.
Our 3 projects are complete, but our portfolio is not done yet. Let's create a Contact Me page so people can reach out to you. The best part is, we're going to use Azure Communication Services to do it. So it's kind of like another project. Let's get to it.
Right here we have our masonstark.com website for our portfolio that we've been building. And I'm going to add at the bottom here a section on Contact Me. So at the top, we're going to have a navigation that says Contact Me, and we're going to be able to go to that and fill out a form, a name, email, and a message that then gets sent to myself at masonstark211@outlook.com so that whoever wants to contact me can do so. This is fictional. Mason Stark isn't a real person, but we're going to see how we can set this up using Azure Communication Services. So first, the way this is going to happen, we have our resource group for Mason Stark with our Azure Static Web App, and we have this blank resource group that I created. So first, let's start by creating our new Azure Communication Resource Group. We'll go to Create. We'll type in Communication Services. And note, we also have email communication services right here. We're going to create one of those as well. But first, let's start with the communication services. We'll call this Azure Communication Services, AIS. Well, it's actually global. Contact Me demo. Then we'll review and create. Our resource is complete. Let's go to our resource. And now if we go to the Azure Communication Services resource, we can take a look at what's inside here. We can see that in the settings down here, if we want to see, there's options. If you did want to get a phone number and set up SMS messaging, you can do that with this service. We're going to go to email. We're going to go to try email. And then here, we have to set up a domain. We could also set up a free domain. We want to set up our Mason Stark domain so that we can actually have emails sent from a specific domain. We're actually going to send emails from Mason Stark. So we're going to connect a domain. We're here. Now we need to connect to an existing email service. So we're going to need to create a new email service if one doesn't exist. That is what we're going to do now. So let's go back to our resource group. Go to create. Now we're going to type email communication services. Email communication services. Let's create this. We'll call this email communication services, AIS global contact me demo. And then review and create. Our deployment is done. Let's go to our resource. We'll go to email communication service. Now within email communication service, we see there is not much in here, but this provision domains, this is what's important for us to set up our domain that we're going to use to actually send emails. So if we go to the communication service, we go back to try email, we see what's going on here, where this is an example text. We're going to use it actually in JavaScript, where if you have a communication services connection set up because the service is deployed, then we're going to send an email from the do not reply at from domain. This is the domain we're trying to set up. We're going to make it masonstark.com. And then that is going to send to whatever email we specify based on the way we set up this. This is going to be in an Azure function. So we're going to actually have our masonstark.com website. We're going to have a contact form. The contact form is going to send to an Azure function that we're going to set up, and that Azure function will have the logic, this logic specifically, that will actually send the email on our behalf. This way we have some separation. The Azure function is our back-end service, if you will, to the front end, so that not everybody just has access to send emails as much as they want. All right, let's finish setting this up to the custom domain. We'll choose the resource group. The email service. And now we need to add a verified domain. We can go back to our email communication services. I think I can jump to it here as well. Yes, I can. Fantastic. All right, now let's add our custom domain. So we're going to add masonstark.com. masonstark.com. All right, the custom domain is deployed. Now we need to verify the domain. So now let's add this text record to our DNS where our custom domain lives. For me, that I'm using namecheap.com. You can use any type of domain registrar for wherever your domain is set up, including Azure. I'm going to set this up off screen, but if you do want more specific instructions on what this is doing, you can click this link and it'll take you to this documentation that tells you more about how to configure the custom domain. I added those to my registrar. Now I'll hit next and hit done. Verification is underway. This might take a few minutes. I'll close this, refresh this page, and see that the verification process is underway. Once this is done, I'll have to configure my SPF and DKIM key and value pairs within my DNS as well. These are some security things that are necessary for actually sending emails themselves. We'll come back when this verification process is done. You might need to hit refresh a couple times. When it is, then we'll configure these other things. Also going to be in your registrar with your DNS. And then after we have gotten those verified, we will be ready to start using our Azure Communication Services for sending email. All right, this is interesting. I hit refresh and it looks like one or more of your domain verifications failed. So let's click this configure button. We have a little error warning icon to see what went wrong. Oh, I see. There's the txt name section that might not be provided for all domain registrars, and I forgot about that because I put in this as the host, when instead the host should be your root of your domain. So you probably need to put in this @ symbol in order to represent the root of your domain for the host rather than the name of your custom domain itself. So let's update this and give this a try again. And just like that, my domain is now verified. For reference, so that you can see what this looks like on my, at least Namecheap for my DNS, is I've got this screenshot that I'm putting up on the screen here, and it's going to show the txt record for the type. It's going to show the host is my @ symbol, the root of my domain, and then I put in the value that Microsoft asked me to put in to verify my domain, and then the TTL I set as 60 minutes. Now we need to configure our SPF and DKIM. So let's configure those now. I'll come to configure. These are some more values we're going to need to add in here. Same thing as what we had before. We're going to put in the @ symbol for your TXT name, but for your CNAME record, make sure you do put in the proper name for these. You're going to have 2 of these for this security record. I'm going to add these to my DNS, and then we'll hit next and keep moving forward. All right, I've added these in. Let's hit next, and then review, double check, verification's underway. Let's see how long this takes. All right, my verification is complete for all of these. Now I'm ready to start using my masonstark.com with my email communication service. So let's go back to my Azure Communication Service. Let's select a domain. Probably need to refresh the page here. Let's do that. Refresh the page. Select a domain. Oh, gotta connect the domain still. Let's do that. Go to the resource group. Contact me. Select the domain, Mason Stark. Yes, yes, yes. All right, now we're connected. Now I can select this domain. I see the do not reply get filled in over here with do not reply at masonstark.com. And then as an example, let's send this to Mason Stark 211 at outlook.com. We'll pull this up. It's going to be subject test, hello world via email. Send this. Email successfully queued. Email successfully sent. Let's check the email real quick. Looking in my email, see I have my do not reply email I just got. This test email, hello world via email. So that worked. So our email communication services is set up properly in our Azure Communication Services account. Now let's create an Azure function locally in Visual Studio Code where we'll make requests to our Azure Communication Services to send the emails and then connect that to our Mason Stark portfolio with a Contact Me page. I'm in Visual Studio Code. I have 2 folders open. One that is the Azure Static Web App locally. So this is my front-end application for masonstark.com. And then I have an empty folder that will house the function for my Azure function code that will make calls to the Azure Communication Services, specifically the email service, in order to actually send emails on our behalf for when the Contact Me page is filled in and submitted. So let's get started. I'll open up the terminal, make sure we know where we are. Let's enter the demo function. You are going to need the Azure Function Core Tools CLI for this. If you don't already have that installed, I'll leave a link to how to install it in the description. If you've been following along the portfolio, then you already have that installed and you're good to go. So within this folder, there's nothing in here. I'm going to do function new. Let's expand this just a little bit. We'll close this so you can more easily see what's going on here. Make sure you can see this. All right. Then we're going to move me to the other side. All right, now let's choose Node. We're going to do JavaScript. Now the Node files are being created in our demo function folder. You can already start to see them get populated with npm install running so that the packages get added to our Node modules folder. When that's done, we're going to specify that we're running an HTTP triggered Azure function, give it a name, test it, and then add our additional code related to Azure Communication Services. So now we have the option to choose our trigger. We're going to choose HTTP trigger. Then we're going to call this contact. Let's do lowercase. Contact me. Email send. All right, so we have now over here the source, our functions with our contact me email send. Right now it's just a get or post API that looks for a name in the query or in the body. Let's update the code to use our Azure Communication Services. In the Azure portal, just a note, we're going to be using this code from this package in order to send an email. So let's install the package, then we'll update the code. Our npm install that communication email package. Now let's close this, open this up a little bit more, move me to the other side. Now let's update our code. All right, I've updated our code. Let's run through this real quick. We have our communication package that brings in our email client. We have a connection string that we're going to need to add to our local settings.json file. We'll do that in just a moment. And then we have our function that is actually going to send an email. So this is using just some logic to actually send an email for us. It'll just send the sender name, the sender email, the message that is put in the contact form. You can customize this however you need when you're using this yourself. And the sender is going to be this email, and then the recipient is going to be our Mason Stark email down here. This function is then going to be used in our Azure function. And so it's going to try to get the name, message, and email from the body that is sent from the front end. It's going to validate them, make sure they're there, and then it's going to send the email. If there's any issues, it'll log it. Otherwise, it'll just let the front end know that the email is sent successfully. So pretty simple. Now let's update our local settings.json file. So go to local settings.json. Let's create a new environment variable for our Azure Communication Services connection string. Let's add this in. Now we'll get this from our Azure Communication Services. We'll go to Settings, Keys, Connection String, and I'll copy this. Then back here, I'll paste it in, save it, and now we should be good to go. Normally, you should never let people see your connection strings. I'm going to delete this by the time you see the video, so it's okay. Finally, for testing this locally, I'm going to add in some logic so that we can test it locally and not have an issue with CORS, cross-origin resource sharing, so that our front end can call our Azure function even locally. All right, now let's start this. I'll do func start, and then we're going to test this Azure function locally using Postman. You can use any type of API testing tool. I prefer Postman. I just like it. I think it works well. And then we're going to add in our code for our front end so that it can connect to our Azure function locally. So we have our endpoint here. I have Postman open here. I have my example message that I'm going to send to my local API. Let's send this and see the response that comes back. Oh, there is an error. Let's take a look at this. Oh, and I see that my error here, it says that error sending email, the specified sender domain has not been linked. It's because I accidentally left my old code from when I set this up with my other domain. Let's do this, masonstark.com. We'll save this. Now this should work. Let's see if we have to, I don't think we have to restart the function. If I send this, there we go. Success, true, message sent successfully. Now let's check our email and see this email that should come through. In our email, we do see this contact form message. So we see that that did work properly. Now let's connect it to our front end and see it working all together locally. All right, let's leave this running. We're going to open up another terminal now. We'll come to our local front end here. Enter demo Mason Stark website. Let's install our packages to start. I'll speed this up until it's done. All right, that is complete. Now let's get this started. npm run start, or just npm start, I'm sorry. All right, our site is up. Let's take a look at it in its current state. All right, we want to add this contact me section into the navigation and also down here. So going to our code, this might be a little bit squished, but I want you to be able to see the changes that we're making here. So let's close this, open up these files, see if we can make a little more room. We're going to go to the app. We're going to also open contact. Let's open navigation. I think those are all we're going to need. Let's close this down and update these. So first we're going to go to app.js. Let's put the contact page back. We're also going to need to add it here. So we'll add contact. That's that this page comes back. Now at the bottom, after we save that, now we see our contact page is back in place. It was there in the code already. We just needed to uncomment that code and add it to the import for the app.js. Now in our contact page itself, we're going to need to do some refactoring. First, I'm going to update the handle submit. That actually handles the submission that occurs when the name, email, and message are submitted. So let's take that logic here, handle submit, see where this goes, make some more space, copy this. And currently it's using a package called email.js, but we're not going to use that. We're going to put our Azure function locally here. Let's see. I think that is the name of, we need to update the name of our endpoint. Which is going to be contact me send. Contact me email send. Let's do that. There we go. We got an error here because it expects a set message and set loading hook. So let's add that in as well. Let's save that. I'm going to make a couple more changes so the values can be captured properly. Then I'm going to add a little bit of logic so that I can make it more easy to see when the message is actually sent or not with the status message. And I'll disable the button when the submission is actually in process. So now let's give this a try. So we have our front end code here, which should send a request to our local function. It's going to send the name, email, and message that are populated in our form. And we should see an email come through locally. Let's give this a try. Put this in. Sure, we'll use that email. Some message here. And we'll send this. We see sending. Now hopefully we'll get an email successful. Email sent successfully. Let's check our email. We have an email from Frankie at frankierevere.com with our some message here, so that works properly. Fantastic. Everything is working locally. The last thing we got to do is set up that navigation space. So I think we just have to uncomment an existing list item and save this. We should see contact right here. So I could come to About page, I can click Contact, and it'll take me all the way down to the contact me page. You can go ahead and make changes too if you're going to use this to any of the other information or social medias if you'd like as well. I'll make changes to the data and some of these other items at the bottom of the contact page if you want to change those. All down here. Our next step now is to create an Azure function, push our function code to it, and then take that new function URL and add that to our front end code, and then upload our front end code to update our masonstark.com. Okay, I'm back in the Azure portal within the resource group that has my Azure Communication Services, my email communication services, and my verified masonstark.com domain. Let's go to create, and we're going to create a function app. We'll use flex consumption because this is the new type of consumption. The old consumption is going away. Use flex consumption from now on. We'll select this. We'll give it a name, func, AIS, EUS, contact me demo. Use East US, Node.js is our runtime, and then we will leave the rest of the defaults and create our function app. Our deployment is in progress. I see I have an application insights resource. It isn't named using our standard naming convention. That's okay. I'm not planning on using the application insights resource for what we're doing. But normally, if I was planning on using it, I would want to make sure it's using the naming convention to make sense of where it is. Same with the storage account. I'll speed this up until it's done. Our deployment is done. Let's go to our resource. All right, just before we push up the code, let's add our environment variables that we already know we're going to need. So from our local settings.json, let's grab communication services connection string. We'll go to add. And we'll grab that endpoint value. Apply. When we were using this locally, we also had to set up cores so that our web browser could make calls to our Azure function locally. Let's set this up for our Azure function using the built-in cores feature for Azure functions. We'll go down here to API, where we have the core setting. Click cores, and now we're going to be making calls from masonstark.com. So that is the domain we're going to want to set in place here. So we'll save that. Now let's upload our code. So in this, let's clear this and we can see a little bit better. We'll go func, Azure, function app, publish, and the name of our function app. So we'll copy this, paste that, and this will now create a zip package that will send directly our code here locally to our function app. And any functions that we have in this local zip of an Azure function will be created to our function app. Keep in mind, if you have some functions locally using this method and you already have other functions in your function app, those other function apps will get overwritten with whatever functions you have set if you're using this method of deployment. All right, our deployment was successful. We see the URL that it gives us. We're going to copy this URL right here, and this is what we're going to use for our front end code to now send it. So we'll go to contact for our front end code, and this is what we're going to add now. Now let's open up our terminal for our front end code. Make sure we're in the right place. We'll run git status. Looks good. Let's add these. updated contact me page. And then we'll push this. This should set off a GitHub action. Here's the repo for here's our repo. We'll go to actions, see that our GitHub actions in progress. When this is done, hopefully it passes, and we should see our Mason Stark website that is updated with our contact me page that can send an email if somebody fills out contact information, sends it to our Azure function. Our Azure function calls email communication services to send an email for us. All right, this failed. Let's double check why. Email.js is used in the headers, but not used. Okay, let's remove that. At the top, we need to remove these. We'll just comment them out. Make that update. Git status. Add. Git commit. Removed email.js import. Git push origin master. Back in GitHub. Let's see, we should have another action running. We'll watch this one. All right, looks like that worked. Now let's go to our Mason Stark website. Go to masonstark.com. We see now on masonstark.com, we see our contact page. Let's go to our contact page. We see our name, email, message. Let's fill in some info. This is from masonstark.com. We'll send this. We see sending. Hopefully we see email sent. That's what we should see. Email sent successfully. Let's check our email. And we see this is from masonstark.com, so that sent successfully. We've successfully set up the Contact Me section for your Azure portfolio using Azure Communication Services, Azure Functions, and Azure Static Web Apps.
Congratulations! You now have a complete Azure portfolio website. You learned about Azure services, created projects, and now people can reach out to you to learn more about you and your skills. If you have questions, leave them in the comments below. I answer every comment to help as many people as I can. If this video was helpful for you, I'd appreciate it if you liked the video and subscribe to this channel if you want to see more content like this. As always, thank you so much, and I'll see you in the next one.